Hello, this is Tomo Wilkins. Welcome to my second part of the CPM calculations, where we'll be covering some additional considerations. I hope by now you have viewed my video about the CPM calculations that shows how the computer actually performs the forward and backward passes. So at this point, I want to cover 5 additional things. The AM-PM versus the noon convention, lags, not earlier than constraints, not later than constraints, and the project finish date. Let us consider the AM-PM versus noon convention. Most scheduling practitioners prefer the AM-PM convention. And what that means, as shown in the upper right area of the bar chart there, is that activities begin at 8 a.m. in the mornings and end at 5 p.m. in the evenings on a normal working day. So the predecessor activity here finishes at 5 p.m. on a certain day, and the successor starts the following morning. What that means is that the finish date of the predecessor and the start date of the successor will not be the same date. And most people are quite comfortable with that. It does, however, complicate the calculation, which the computer does, so you don't have to worry about it, except you should understand it. And that has to do with calculating the finish date. So for activity B, if the start date is day 6, the finish date is calculated as the start date plus the duration minus 1. So for activity B, we have 6 plus 10 is 16, and minus 1 is 15. And that's because the working days are inclusive of those days. Now, some people prefer to have the predecessor and the successor finish and start on the same day. That is, they'd like to see the finish date of the predecessor and the start date of the successor to be on the same date. So on the lower half, you see the noon convention. And so the predecessor activity finishes at 11:59 a.m. and the successor starts at noon. So that gives you the convenience that the dates are the same, and the calculation for the finish date is simply the start date plus the duration. However, it does add the little complication that all activities work half a day at the beginning and half a day at the end. And most people are not too comfortable with that, and therefore they do prefer the AM-PM convention. I don't have any statistics, but I would not be surprised if 95% of scheduling practitioners use the AM-PM convention. So hopefully that will explain the +1 and -1 and the finish and start calculations in the forward and backward passes. Let us now take a look at some new angles that were not in my previous presentation, just to keep it simple. So I've added 2 elements now to the network that we had. One is that in between activities B and C, there is now a lag of 2 days. And a lag behaves just like a real activity. It takes up time. But of course, there are no resources expended in that time. An example might be if activity B is pouring concrete and activity C is installing the structural steel, you need some time for the concrete to cure. So it is a good idea to add 2 days for curing into the schedule for that purpose. And then the other thing we added here is the not earlier than constraint on activity E. So in this case, it says the activity E cannot start any earlier than day 11. So let us look at the forward and backward pass calculation again with this new scenario. So we have the forward pass early dates for activities A and activity B as before. Okay, and then when we get the other path that we need to evaluate for activity C because it has two different predecessors. So we get the start date of 1 and finish date of 8 for activity D. But now activity E, instead of starting the next morning on day 9, can't start until the morning of day 11 due to the constraint. So E then would start on day 11 and finish on day 13. Now we can see that for activity C, the earliest start date would be the additional 2 days beyond B's finish. So we have 15, and the next morning is day 16, but we add 2 days of lag, so it becomes the morning of day 18. And that would be the controlling date for C, because E, even with the constraint, it is still well before B finishes. So we now have a finish date of day 24. So let us see what happens on the backward pass. So we have here now a late finish date for activity C of day 24. Again, we're using the default for a project finish from the forward pass, day 24. So applying the formula on the bottom now, start equals finish minus duration plus 1, because of the AM/PM convention, we get 24 minus 7 plus 1 is 18. Now, for activity B, even for the backward pass, we have to consider the lag. It is like a real activity in the sequence. So B cannot finish as late as day 17 because we have to account for the lag. So B has to finish no later than day 15, in which case it has to start no later than day 6, and A finishes day 5 and starts on day 1. And for the green path, E now can, however, finish as late as day 17, 1 day before C needs to start, in which case it would have to start on day 15. And now activity D, notice that the constraint does not come into play on the backward pass. So activity D needs to finish no later than day 14, in which case it needs to start no later than day 7. So now we have our late dates. And now if we look at the floats, okay, you can see the float for activity C is 0, late minus early, 24 minus 24. The same with activity B and activity A. Okay. For activity E, the float is equal to 4 days, and for activity D, the float is 6 days. So E has 4 days of float, and we can see it graphically, right? And D has an additional 2 days of float, which we can also see graphically. But E doesn't have the full 6 days float because it is constrained by the not earlier than constraint. So I hope this helps clarify how a constraint and a lag impacts the forward and backward pass. Now let us look at another situation. And so we still have our lag and constraint in the picture here, but we've added a project finish date. So let's assume the client says, I need this done by day 22. So let's see what happens. Our forward pass works as before. Okay, so we come up with a finish date of day 24, just as we had a moment ago. And now we start the backward pass by using the project finish date as the starting point. So the late finish date for activity C is no longer day 24, which was the default if there were not a project finish assigned. So now it is the project finish date. So the late date for C is day 22. Using the formula 22 minus 7 plus 1, we get a late start date of day 16. Then again, accounting for the lag, we have a late finish date for B of 13 and a late start of 4. And activity A has a late finish of 3 and a late a late start of day -1. So notice I've extended the calendar here on the left to go into negative territory. Okay. So what this is saying is that we should have started the project 2 days ago, according to the customer's needs, right? So something has to be done with that. Let's look at the green path now. Okay. So again, E needs to finish by day 16, the day before C, its successor wants to start. And so in that case, it has to start no later than day 13. And for D, it has to finish no later than day 12 and start by day 5. So if we look at the float now, you notice for activity C, it's the same formula for float, late minus early. So we have 22 minus 24, and we have 2 days of negative float. And for activity 10, the same thing. We have 2 days of negative float, 13 minus 15, and we have minus 2 days for activity A. For activity E, we have 2 days of float, the late date of 15 minus 13. Okay. But for activity D, we have 4 days of float, the late date 12 minus the early date of 8. And the reason for the different float on the green path is that this constraint is keeping activity E from starting any earlier, so the early date is pushed closer to the late date. Okay. So I hope this gives you an understanding of what happens if we impose a project finish date. Let us look at another aspect of a project finish date, however. Let's assume the client says, I need this project finished by day 26. And let us assume that we're going to have a not later than constraint on activity B. So we're saying B should finish no later than day 13. So let's see what happens. We look at our forward pass, and again, we come up with day 24 on the early finish for activity C. But now for the backward pass, the calculation starts on day 26. So the late finish date for activity C is day 26. Still applying the same formula, 26 minus 7 plus 1 gives us day 20 as a late start date. Now activity B cannot finish as late as day 17. If you back this off day 20, 2 days for the lag would be day 18, and the prior afternoon would be day 17. We have a not later than constraint on activity B. So the late finish date for B is day 13, in which case it has to start on day 4 and activity A finish on day 3 and start on day -1. The green path down below, now E can finish as late as day 19, the day before C starts. And so it would need to start on day 17. And activity D can finish as late as day 16. Again, the constraint does not come into not earlier than constraint does not come into play for activity E in the backward pass. So now let's look at what happened to the float. So our total project float there is 2 days, positive. We have 2 extra spare days, if you will. But notice activities A and B have negative float, -2, because of this constraint imposed, which is more restrictive than the project finish date and the logic of the activities between B and the project finish. Activity E has 6 days of float, again, late minus early, and activity D has 8 days of float, late minus early. And the difference of the float, again, is due to the constraint here on activity E, pushing the early dates out further. So one thing to consider is that activity C is actually no longer critical. It has positive float. And this leads us into a discussion of critical path. And PMI, unfortunately, adds some confusion to that by the terminology, and I will be covering that in another video. So we have here a critical path on A and B with negative float, and we have a non-critical path, DEC, with positive floats, even though activity C is determining the project finish date. So I hope that clarifies some further understanding of the impact of applying constraints and project finish dates and how lags come into the picture. Thank you for watching, and I would welcome your feedback.